Introduction here already. So welcome to our webinar in function of Cook Smart Products. It's an introduction to the smart product exploration. Is the first webinar of a series that we will organize. So every 2 weeks, in 2 weeks from now, we will have a second one and a third one. You can see the dates here as well. So today we're gonna basically introduce the, let's say, the scope, but also a little bit of the theory. So I think in terms of what I depends on what you're looking for, of course, but it might be the most theoretic presentation or slideware that we will give. This is today, and then in the 2 weeks we have one that zooms into the problem space and stakeholder needs exploration, and 2 weeks after, on Friday as well, we have one that will, a webinar that will go around the solution space exploration and also validation. Now, first of all, I would like to thank you for coming. Geert will take control, I think, in a moment, and we'll start with the presentation, and we'll introduce a little bit of theory of or the problems that are come along with let's say smart product exploration, and give a little bit more of a theory around the product life cycle exploration and the content that we will bring. So Geert, the floor is yours.
Okay, thank you, Thomas, and I will share my screen, which should be now visible.
And it is.
Okay, what I will discuss in this first part is a system engineering approach to smart product exploration. This, in short, very quickly introduce the smart product challenge, then have a look at how the ISO, IEC, IEEE system engineering standard are defining lifecycle stages and lifecycle processes, because this we will use to address the new product exploration activity, which is about mastering the fuzzy front end of product development, which we will introduce in the third part. I will then look a little bit deeper into the business analysis and then explain a methodology how we could actually master this fuzzy front end in a product research stage, and by using stage gating for that, and how we could do that in a practical manner and illustrate it a little bit. Okay, smart product challenge. I made here a slide with a lot of buzzwords that are going around today around everything related to digitalization, connectivity, industry 4.0, sensors, cloud, name it. All these things play a role in trying to give an answer to the needs of users and other stakeholders. What this actually illustrates is that we have to deal with a lot of complexity, and that is actually where this system engineering could help us in answering basically three main questions, and that is, what do our customers and stakeholders need? What do they want? What is the need? Secondly, what can we offer to answer that need, the solution, and how can we make some money from it? Because as a commercial organization, you want to survive. There we need a business. Now, it is not enough to just have an idea about these answers to this question. We have to validate that to make sure that the solution for which we want to create is actually desirable for the customers and the stakeholders, that it is feasible, and also that it is viable, that we actually can earn some money from it. Now, in relation to these three main questions, we have also a question on what kind of competences and capabilities do we need to be able to do these things, and these capabilities can be in-house capabilities or capabilities that we need from partners and suppliers. Now, one component that could be highly valuable is this system engineering approach, which is actually based on work of the International Council of System Engineering, which have developed also a complete set of system engineering standards. And the most important thing about that is actually made to deal with the high level of complexity of systems, of complex systems. It actually goes back to the development of large military systems, of things like the Apollo program. But actually, since we are dealing with complex systems when we do digitalization smart products, it can be quite helpful to do that. Let me introduce the first aspect of, let's say, the view on the system life cycle or product life cycle. If we want to start from an idea and bring it to a solution in the form of a product to the customer, we can discern three main stages. The first one is the new product exploration stage, where we are going to investigate the problem and the solution to see who is the user, what is the market, the business, etc. And this we will translate and create a validated concept of what we believe is a solution that is viable for the organization and can answer the customer needs. Then we can do the planning of the actual product development. That is the product development itself, but also all the operations and business setup that needs to be done to launch the product, and that needs to be done prior to the development of the product itself, that will then yield a qualified, documented product that can be delivered to the customer. If you look into a little bit more detail, these stages can be further divided into phases, and we will look into more detail here in the new product exploration phase, where we discern a problem research and a product research phase. The planning stage can be subdivided to a specification and the actual planning stage, and then we have the product development, defining the architecture of a system or a product, designing it, prototyping and qualifying it, industrialization of the product, that is bring it into the production environment and ramp up towards volume production if that's relevant, produce the system, distribute it, install it, operate it, and then finally at some day retire. These phases and stages line up, or is the alignment with the generic life cycle stages that is defined in the ISO standards, where we have the concept, the development and the production stages, and then utilization, which is operation, and support stages that let's say coincide, and the retirement. So this, you see here, have some alignment there, but the engineering standard only gives a very high level stage gating, which needs to be tailored towards the application, the kind of product, kind of life cycle concept that is relevant for the product at hand. And so we defined here one way of looking at that for typical smart products using electronics as an important element. Each stage gate or phase gate is actually situated at instances where major decisions need to be made. For example, after you really investigate the problem and the solution and made a conceptual proposal, you have to decide whether or not it's useful or meaningful to continue the development process and start the processing stage. The planning stage. After the development of a product, at a certain moment, the product is ready and can be handed over to the regular production, and that's another important aspect of the stage gating, that apart from the decision, it often includes also transfer of responsibilities between different teams in an organization. But all this can be tailored to the specific needs of the specific product, the specific activity we have to deal with. Besides lifecycle stages, there are also lifecycle processes defined, and these processes are intended to cover all major activities that are relevant for the lifecycle of a product or system. There is a first set of so-called technical processes, which in the next slide I will discuss in a bit more detail. But this series of actually 14 technical processes can be divided in processes that are related to the realization of the product, development of the product, the evaluation of the product, the operation and maintenance, and then the disposal of the product. Now, as a support to these technical processes and to govern the product development and the product lifecycle management, so-called technical project management processes are defined that contain a planning process to make the project plan, the assessment and the control, decision processes, management of the configurations. Typically, you will pass over or do different configuration or different versions of a product that is governed by configuration management. You have risk management and, of course, quality control and management of what you're doing in the project. To be able to do that, you need to measure things to know if the targets are met. This is the measurement process, and this needs to be managed in the information management process. So these are all the project management activities of processes that support the technical processes of a product life cycle. To get a product to the customer, we have to be able to retrieve, to acquire all the possible materials, parts, services to build and create the product. And then we also have to be able to supply the product to the customer, and that is then governed by two agreement processes, the acquisition process and the supply process. And all this then is made possible by the so-called organizational project enabling processes as a company that provides the infrastructure, the people, the knowledge to be able to build products. The life cycle processes actually govern or are related to the methodologies used to build products and do the product management, the portfolio of the company's portfolio, and then the quality management. So this is a complete overview of the whole set of lifecycle processes that are described in this 15288 standard. And now let me go a little bit deeper in the set of technical processes, which can be further divided into processes that are related to defining the problem, the needs that need to be answered in the business analysis, the stakeholder needs, and the system requirements definition. And then we have actually the creation of the solution, architecture definition and design of the product. Then we have the realization, which includes the implementation, which is actually the production of all the parts, and then the integration of all these parts into the full system. So actually those two are production related processes. Then you have the transfer towards the customer to get all these technical process to get the product at the customer where it can be used, or at the user is better. Now, we need evaluation of a lot of all aspects that need to be done here, and there are 3 what I call evaluation process defined as the system analysis. These are all kinds of techniques or activities related to analyzing what is being made. There can be modeling and simulations, etc., measurements being taken. Then we have the verification processes, which checks if all the requirements that have been established are fulfilled. So this verification process checks if the system is built right. The validation process checks whether the needs are covered of the stakeholder. And actually, this is the evaluation whether the right system is built. So the system is built right, the right system is being built. Then we have to bring that to the user using the supply process, where it can be operated. And operation often means support and maintenance. This is covered by the maintenance process, which can be executed by the user, but also the organization developing the product can still be involved in maintenance there. And at the end of life, the product needs to be disposed of. And also there, it can be a task of user or the organization itself. And this also means that we have to look in the development and production activities towards maintenance and towards disposal. Then this slide gives an overview of all the processes. I will not discuss it again. Also this, but we will provide the presentation, and then you can have a look at it in more detail, especially in how these processes are interrelated. This is another way of looking at it than what I presented in that E-diagram. Maybe just to indicate that all the processes, these are inside the product development and lifecycle project, while these processes are outside the project but inside the organization doing the development. Now the question is how do the lifecycle stages link to the lifecycle processes? It's not so that a specific lifecycle stage is linked to a specific project. So what this diagram shows here in vertical direction are all the different lifecycle stages and phases we have defined. And here we have the different lifecycle processes, at least the agreement and the technical ones. So we do large. The slide is not big enough to have all the project management here. And these colors indicate whether a certain lifecycle process is being prepared, being implemented, executed, monitored, or improved. And you see colors everywhere. That means that in each stage or each phase, the main part of all the processes are actually in some way active by either being prepared or being actually implemented or whatever. What you do see is, of course, this green diagonal, where you see that there is for each stage, I would say, some core processes that are actually being executed mainly in a specific stage. So, for example, and in the new product exploration stage, we focus on the business analysis and the stakeholder needs, but at the same time, we will prepare all the rest. Actually, what we do is we look forward into the future and start defining the needs and prepare what we will be needing to develop and support the product over its lifetime. So let us have a deeper look into the new product exploration stage. What do we need to explore there? First of all, we have the user and stakeholder related aspects, or let's say the desirability of the solution. Does the solution that we are thinking of really answers the problems and the needs of the stakeholders to get those things aligned? Then we have product-related aspects, technical feasibility. Is the technology we envision to use, is it ready? Is it available? What is the readiness of it? Is it available? Is it accessible? It's not because you can make something in a lab that it can be retrieved on an industrial scale, or even if it's available on an industrial scale, it may be not be accessible as for you as a company because you're too small or your product's production volumes are not too big, whatever. These things need to be covered. You have to check whether the feasibility of the life cycle we envision is possible and can it be supported? Can we have do we have a supply chain which is available or is able to supply what is needed? And all the enabling systems, are they available? Enabling systems are everything you need, services, systems to support your product. That can be an operational support, like you need a 5G infrastructure if you have a 5G application, of course, but you also need a production plan to build your product. All these are enabling systems and they must be available. And then we have to look at all the risk scenarios, resources, and costs for the different concepts. And then we have the business related. Does it fit with our company? What about market, environmental aspect? Anything you can do. You have to relate it to the business and how it operates need to be covered to get to the validated concept. Now, an important challenge we are facing here is that these problems, stakeholder needs, solutions are interrelated. We start from certain idea about a problem of a stakeholder that needs to be answered. We have to really understand what the stakeholder needs to come up with a solution. And then we have to check whether the solution actually answers the problem. And for that, we may have to go back and test it with the stakeholder. And so we get an iterative process to get to a clear view on what is actually needed by the stakeholder, what is desirable, what can be done to as a solution. And at this intersection, we can find a viable solution, but not all possible feasible and desirable solutions are necessarily viable for us as an organization. There will be a subsection which is, and that's what we need to find. Now, typically, this kind of iteration is a bunch of ideas running around, being discussed, and we may have to do some testing and evaluation. So how do we get control of this to get it managed, especially if we start doing tests and using resources? So a way of doing this is to start with a so-called low-cost problem research phase, which creates a research plan on all the questions that needs to be elaborated further upon. And this starts then a stage-gated product research activity to get through this iteration process here. So what it's, or another way of looking at this, we start from an idea, and what we try to do in this new product exploration stage is to funnel down all the options we have at the beginning, and then options, a lot of options creates also a lot of uncertainty, to get a better and clearer view on what can be a good solution that answers what stakeholders need. But it's clear that the further we go in that activity, that the efforts and the costs will increase, and this looks like an exponential curve because it can be really exponential. and we have to be careful because we do not like that kind of curse that much. So to keep that under control, we would like to have some stage gating in and decision points whether we continue with a certain activity further. And this then leads to this validated concept from which we can base our product planning and product introduction activities. A quick overview on or making the link with the system engineering activities and specifically the business analysis process and the stakeholder needs processes. What the business mission analysis contains or covers is this problem solution space exploration, defining a preliminary lifecycle concept and identify who the stakeholders are. And this leads then to a set of outcomes for which the so-called business requirement specification is let's say, a core output which defines, specifies what the business needs are from or the requirements are for the organization that will develop the system. Based on this, we look at more detail into the stakeholder needs and requirements. From those we have identified here, we define lifecycle concepts and come up with a stakeholder requirement specification. I will later explain what the difference is between a need and a requirement. But let's go on here. And based on the stakeholder requirement, we then go and have or look or work out the system requirements. Now, the system requirements itself is already part of the new product planning to come up with a system requirement specification. But in the exploration phase, we have to look at the feasibility of the systems and the system solutions we are looking to. And that is part of the preparation that needs to be done there. Now, this is not enough. As said, we have to look at all the other technical and agreement processes that need and the kind of constraints these processes will have on these business or all these requirements here, or vice versa. And of course, we also have to look at the availability of everything that will be needed. And if we bring all these things together, we get a validated concept, which can then trigger the start of a product planning process. But as always, this is the logic flow. This is not the chronological flow. We'll have to iterate through these processes and activities to come up with a validated concept. In the very beginning part, this problem research part, everything is open at that moment of almost open. This is the most fuzzy part, and there, it's not so obvious to do their stage gating, but to keep that under control, we can start with a pre-study, which is low cost and therefore mainly based on things like desk research and etc. to cover and to get an idea of all the relevant topics, clearly identify the problem and the need and options for solution there, make a first filtering, and identify then all the aspects that need further exploration and validation, and for which we will need more means and resources to do that. So what comes out of this product research part is paperwork, or at least electronic paper work that explains the view on a possible solution, and that is then brought to the decision makers on whether or not we are going to invest in further exploration in a product research part. As said, this is not very fuzzy, and a way to deal with that is to use a kind of time box approach, where you work with a fixed time period, a limited financial budget, and a budget for people to do the study, and that's a way to control here the time, the effort, and the financial means. Then we go into this much bigger study, the product research itself, and a way to stage gate that is by doing that based on milestones which need to be achieved in a logical sequence. We start with the business requirements, for example, to create this business requirement specification upon which we look toward the stakeholder needs, which we create a stakeholder needs statement. Then we go into more depth of the defining the life cycle concept and validate them. And based on that, we can go to the stakeholder requirements and go to stakeholder requirement specification. So what we follow here are the different the outcomes actually of the business analysis and stakeholder needs processes of the system engineering approach. And then at the final stage, we explore possible system solutions to come up with a validated concept. But as said, we will be needing iteration, maybe come back on certain things with new insights. That's unavoidable, but this is then controlled with state gates, where we make decision on continuing a phase, go to the next phase, return to a previous phase, hold the project for some time, or stop it. So in that direction, we have something that looks as a time progress, but actually one should look at this as a maturity evolution axe, where the further we go in that direction, the higher the level of maturity is on the understanding of the business and stakeholder needs and requirements. Quickly, some basics on this business analysis. What is being addressed? That creates the problem opportunity statement to clearly understand what problem we are dealing with. And it's good to know that this can be very broad. This problem can have different contexts. It can be a problem which is internal to the organization itself. For example, if you say we want to upgrade our production to an Industry 4.0 level, then this is a system engineering effort or an exploration effort, which is an internal one with an internal customer. You can have external customers for which we have to create a customized solution, like an infrastructure or building products for a certain customer, or it can be a typical product sales where we produce products for a market of customers which at the moment of development we do not know yet. And then, of course, we have the organization context, where we look at the mission of the company, the concept of operation, what kind of company do we are, what are the strategic plans, and how does all this fit in our ecosystem in which we work. A second, so we first have what do we do? And then the second question is, for who do we do it? Who are the stakeholders? And there are quite a few of them. It's not only the user or the customer. We have a set of stakeholders which are directly related to the company. We have the company itself, but also its management, employees, etc., related to the customers and the users and the society. So this is just an indication as inspiration to not forget certain important stakeholders. And then we have to come up with certain so-called solution candidates. How will we address this problem? And for that, we have to establish the life cycle concept of the solution. That's not only how the system will be used, but also how it will be developed, how it will be produced, how it will be delivered, etc. All these things need to be defined. and that defines then certain candidate solution classes. Now, I will quickly go through a short a case to explain a bit what all this means, and we have we use for this the coffee case, and what it's about. Assume that we want to provide a solution which is about providing quality coffee with a value-adding experience for the active professional in a work context. It's a kind of smart solution, or that might be one of the possibilities to have a smart coffee machine. If we want to do something like this, we have to do the business analysis, and there are different ways of creating the business and revenue models. We can sell equipment, so coffee machines. We can sell coffee and its accessories. We can have things like a coffee as a service model. We can have things like community membership. If we want to create or have these kind of models active, we have to align this with the life cycle concept, or the life cycle concept needs to be aligned with the business objectives. And there are different possibilities where, for example, for the first one, equipment production, retail sales, after sales service would be the typical model to deal with that, or life cycle concept. While for the second part, consumable sales, orientation, active community, coffee promotion are important things. If you go as a coffee as a service, then really you have a kind of 24/7 online support necessary, etc. So these are aspects of the life cycle concept that needs to be aligned with the business requirement. And then we have to come up with solution classes. What kind of possible solutions could we provide for that? We could have a vintage class that gives a lot of experience, or there are other possibilities, more classic way of making coffee, the Clooney approach, or the really smart barista for a professional concept. So if we go into a research, product research stage gating, we have to validate the different options there. And the first part is the business requirements. And something what could be a business requirement here could say that, for example, for our company, coffee machine production is still a core business. So this will not be put off the shuffle. We will keep on doing coffee machine production in-house, the high end, and at a low bit some capacity limits, low end we can subcontract, and there we do not have capacity limits. These are kind of boundary conditions that are specified in a business requirement. We are looking for creating some margin outside production. Our sales department can be turned into a service department. We do not intend to go for selling our coffee and accessories ourselves, but a partnership is an option. These are things that could be defined in such a business requirement specification. Then we need to better understand what is needed by the stakeholder, and here I define the need. That is something that is wanted and required. So let's have a look here on what the stakeholder needs are, and I emphasize a few words here: quality, experience, professional in a work context. And I answer the questions that we need to answer. What is quality for a professional? What do we understand by quality, and what is kind of experience is expected? And what are the constraints? In a work context, it's not only about the coffee drink, it's also about the management of the company. So what are the exceptional operational scenarios in this kind of work context? And for example, it could lead to the decision that, this vintage solution class is something which is not compatible with the work context time constraints, and we have to drop that one. The life cycle concepts need to be validated. We could look, for example, to two concepts: one with a coffee bar concept with a bartender, or a self-service concept, and this needs to be then tested, evaluated with, and Thomas will explain more, or in next session we will explore or explain better or more in depth on these topics. We have to look at supply, service, support, etc. So not only the user, but every supporting concept, and see what kind of solution class could fit with certain life cycle concepts, and everything needs to be aligned with our business specification. The next phase is then translating needs into requirements, and the difference between a need and a requirement is that a requirement can be verified and validated. And for example, quality is something which is not verifiable unless you specify what it is. And in this case could be that we say, okay, we want only premium brands that are being used for the coffee, and it must be fair trade coffee, for example. Then we a need is translated into a requirement. And of course, there are some constraints: a maximum cost per coffee, a maximum time to make it, minimum amount of tastes that need to be available, aspects of certain characteristics, actually, like things like safety in a work context. We do not want to have glass or something. We cannot have open coffee cups being transported, etc., and some additional requirements there. And all this then needs to be combined into a validated concept, where we look at the feasibility of the system concept and the realizability, things like availability of sensing systems, user interfaces, software development, some definition of preliminary system requirements, and create the complete dossier which is consistent with all the possible needs and requirements that have been defined. And that then together with the development plan is then the start for a possible planning phase for a new product. Now, all this is written down in a guideline which we will make available later this year, which gives some background on it. And okay, this closes my talk, and I'm afraid I run over time. So Thomas, sorry.
Just slightly. Let me share my screen. Okay, I'll try to. Well, I don't think I will make it before 4, but let's try to take some speed. Yeah. So basically, he has already introduced the coffee machine. So basically, what's happening is you had an ordinary coffee machine. Let's say that we make a coffee machine, and we add some intelligence, some sensors, and some communication, and it becomes a smart coffee machine. So it seems relatively simple, right? And we add some sensors, and suddenly it becomes smart. But I mean, before even thinking of putting any of those, you could ask yourself, what functionality do we actually want to add? We can do a lot of things. You could have a smartphone application to control your and configure your coffee machine. You could work with voice commands or even face recognition. It could be automatic inventory controlled B2B. So basically what happens is, even though we just add these sensors, actually a lot of things change, both internally for the organization, but also functionality, and also with who you partner with, from who you buy from. So basically you can see that rather than the functionality on its own, it's sort of a changing landscape for your own company and also for who you're selling it to. So you have these competences, let's say in engineering and creating the best coffee machines in the world, and suddenly you need new expertise, new competences in order to actually add this intelligence, these sensors and communication, but you also get new stakeholders, new users. Other people might be interested. They have maybe earlier expectations or other expectations. So, I mean, a lot of things are changing. And I think in general, what we could say is that when going from a normal product into a smart product, or when starting up a company and wanting to create a smart product ID, I think what can just say is, just like with ordinary coffee machines, if you start from zero, or whether if I'm a software engineer and I want to start making coffee machines, is a lot of questions that, because we do not yet have expertise in these domains, a lot of new questions arise. And as I said, these questions don't only specifically focus on the hardware, on the software, or even in the interfacing between. It's everything from, let's say, company fit, your business, to your internal organization, to the technology used, but also what stakeholders actually want and need. And of course, the business model that goes along. I think Geert already gave quite a lot of examples that you can go in a lot of different directions. And I think the digital component even makes it even broader. The coffee as a service, maybe the razor blade model. I mean, you could go a razor blade as in you sell a coffee machine cheap, but you ask for the let's say the capsules like Nespresso. So a lot of ideas go along with developing, and that's a challenge. So it's a product ID, and in this case, we're of course focusing on smart. But I think in general, what we want to say is that what is mainly important is that we are able to answer whatever question that goes along with this development or this exploration. So basically, if we think of all of these questions, what we can actually identify is that there's two, maybe three, but two facets or aspects that are very important. So we have business, everything related to your own mission, what and how will we do it as an organization, and of course the stakeholder being as well the organization internally, but also for who do we do it. And if we combine these, we can come up with a concept. And of course, coming up with a concept requires us to actually also validate and if we're actually doing the right thing. So I think the difference in between the let's say the upper layer business and stakeholder needs is that these are actually exploratory activities where we try to learn from the, let's say, relevant business models, the strategy of our own company, towards what actually stakeholders need and how we could actually solve that. We explore this, and what we learn from this, we can use to actually decide upon which concepts upon the concept that we actually have. So it's actually, the concept just is a sort of an analysis where we try to validate whether we are actually meeting the stakeholders' needs and whether we are actually meeting the business requirements that go along. So as Geert explained, we have these two large, let's say, parts of smart product exploration. We have a problem research where we try to find as many insights, and the product research where we're actually starting to validate the problem space and look for solutions and viable solution classes that can actually answer. So this is not a very clearly defined line in between. I want to make sure that what is happening, and I think the slide of Geert was very interesting for that, is that as we go along in time, effort and costs will increase. And so what the problem research is a very early and preliminary research into the problem, which is quite low cost in general, which is just looking for, let's say, strategic fit and identifying at least stakeholders and, let's say, large scale generic needs, which can then lead to, let's say, a preliminary concept definition or ID definition, where in the product research, we're more looking to actually validate these stakeholder needs, look for viable system solution options, validate various lifecycle concepts. So not only what the product is itself, but also looking for how will we actually distribute this, how do we package this, how is an end of life going, what certification is needed. And of course, I mean, we want to validate the stakeholder requirements and also, of course, look at the end user. Yeah. as Yes showed the slide, I reworked it a little bit to fit the design, but basically these are actually the phases that Geert introduces. With every time a milestone is met in between two phases, and then we can continue. So this is not really a linear process, as Geert explains. It's more of a maturity. So where you have a rough outline of what you're aiming to do. At the end, you should actually have, let's say, a very clear product concept. So before all of these steps, of course, we have more of the problem research where we do activities such as disk research. It's an early exploration of that problem and opportunity space. At the end of this whole process, what we aim to end up with is a validated concept. Now, this is a very broad definition. Like I said, the questions that we need to answer are not only functionality related. When we talk about a validated concept, it's also not only functionally or technology related validation. It's you actually create the whole story. Sometimes it doesn't have to be already perfectly defined, but you need to have general idea of what way you're heading. Think of what I said around packaging or distribution. These are things that do not happen directly when you're developing a product, but are very relevant if certain requirements affect your solution. So it's the whole story. These are basically all product lifecycle concepts. So they go to sales, marketing, business models, the end of life, how you will support. And basically, in general, we're looking for who are my stakeholders, the needs, company fit, etc. To basically, we actually want to introduce, let's say, tools for product exploration and concept validation. So we have a tool which is called the Smart Product Maturity Scan. And this actually covers this, let's say, whole process of exploration. So it's not something that only focuses on business requirements. It's actually a maturity scan that should, or it's let's say, designed to guide you with this exploration phase. I will explain it a little more, but it's based on the ISO standard that Geert already mentioned. So basically, ISO, for those that do not know it, is an international standard. I mean, the 15,288 that we're talking about, but there's many standards. But they give, say, in this case, it's a common process framework that can help us describe a system life cycle. So why do we use this ISO? Why don't we make up our own maturity scan? Because it's basically only one of the, I mean, it's a good standard. First of all, it creates, let's say, the only commonly and widely accepted framework to actually describe all of these processes. And then, of course, why do we make something like this? Is if you're developing in these new domains of smart products, then this is of course a new opportunity, but it also increases the complexity and the challenges that go along when an organization like yours is actually wanting to create and utilize certain smart products or systems. So because of that, you need to come out of a certain comfort zone where before you were creating, let's say, coffee machines, and you had the processes and the infrastructure to actually do this. The moment you have to come out of that comfort zone, it's actually easier to have a common framework or process that you can, or base yourself on, because of these domains that now are not part of that expertise. So the maturity scan is basically aiming to provide you with insights in these competences and processes and activities that go along from conception of an idea to actually operating and an end of life of a product. The maturity scan consists of two large parts, let's say, or the organizational capabilities basically assess the organization itself, and mainly the knowledge that they have for developing products and the product life cycle. So it's basically, it looks at the status of your company, and the competences that are present and the capabilities that it has. The product development status is actually a project management tool, or project follow-up tool. So it looks at the status of your product or the solution, and of course the lifecycle managing, how that project is managed. So it's quite different from each other. organization looks at capabilities. The product development status really looks at that project individually and how you are progressing in these activities that go along with it. Organization capabilities, I will give a short demo, but I think we're really running over time. So the organization capabilities basically you have a target and a score, but you can see that for each of the criteria, and there are 43 as you could see, we actually use the same levels. So either there's zero knowledge in the organization, or you have, let's say, senior or expert knowledge in the organization, and you're really able to fill in this expertise or this competence. So it basically focuses mainly on the organization and the internal knowledge or the ability to actually subcontract a task like this or a domain like this. The product development status is completely different. It actually looks at, it identifies what you should be focusing on and different domains of, let's say, this product exploration. And it really focuses on the jobs to be done when doing these domain working in these domains. So the levels are actually quite specific to the criteria. They actually describe the status of that activity. So as you can see, I give an example here, I think on user needs. I don't know, there's 73, if I'm not mistaken, criteria. So it's quite a lot bigger, but you can see that the levels are really specific to that criteria. If we then look at the maturity scan itself, this is a high-level view of how it looks like. That makes it easy to demo it for you guys. So basically, as I said, we base ourselves loosely, not everything, but loosely on the ISO standard 15288. So you can see a reference to what process or activity that we refer to. Not every of the criteria are directly found in the standard, but in that case, we do map it under the activity of the ISO standard. Next to that, you can see the criterion, so short description of what it is. As an example, the profit model evaluation, and then we describe and clarify what we ask and what the definition is of what we are reading. So next to that, it's the assessment tool itself. So you can set a target for yourself. This can be something that for the project management tool, you can actually use as a follow-up tool and reassess 2 months later, let's say. So you have a target, and then of course the score is what you meet at this current moment. And then you have, of course, the 5 levels. So the goal is to self-assess. The self-assessment will hopefully lead to actually identifying gaps in your organization or in the project itself, and then these gaps can actually be used as a focus point, as focus activities for the next iteration of your project, or in case that, let's say, it's for the organization maturity, that these gaps can actually help you actually recruit either internally or externally people with competences in these domains. So it's a follow-up tool, and it's a self-assessment tool. I think it's a very important factor. I think if you need to score, always go lower and don't overestimate yourself, because that's I mean, it's better to identify that maybe you're not yet done and work a little bit more on it than thinking that you have all of these competences and expertise and go sort of blindly into developing and pouring money into a project. I'll give you a very short demo. I don't have so much time, but this is then the actual maturity scan. I'm gonna zoom in a little bit. This is the instructions, so you can see that there's quite a lot of explanation. And then, as I said, we have the organization maturity, and then the product development status here. I'm just gonna look at, so the organization maturity, as you can see, has the 5 levels, has a target level. And if we go over it very quickly, it looks at all of these product lifecycle processes. Think of design, hardware, software, service design. So are you able to actually design hardware for any given product, whether it's a smart coffee machine or an ordinary? You can actually score this. If this is too generic or too broad, then you can always also choose to split it up and focus on certain aspects. you can, and then it goes down. It also it's not only to product lifecycle processes, you also have a lot of project management, and then of course the own organizations such as hardware, HR processes, IP processes. The same, let's say, framework is actually used for the product development status, but here we really focus on a lot more. We focus on the exploration, we focus on stakeholder needs analysis, business needs analysis. So it's actually in line with what both Geert and I have been telling of these main aspects or facets of actually product exploration. These are a lot of criteria. I'm not going to go over them. What I do want to show is, so we have this status, we have this target, and then we have this score. So it's relatively easy to score them, of course. So you can see that the color then fills the actual level that we scored. The same here. What I actually wanted to show is if you self-assess a part of a whole, or the whole assessment, you actually also have a report on how you score for each of these criteria, both in, let's say, the large product lifecycle processes, but also more in detail for each of these, let's say, the exploration process and the development process. We also use color codes to annotate where scores are low. But of course, as I said, it's a self-assessment tool, and I think definitely when we go here into development, this is again not really a linear process. But if, let's say, architecture would be scored a 2, but you're already actually looking at design, then I think this is something that you should be able to identify as being a gap. How can you start designing your product when you actually did not make final decisions on your architecture? So this is really important as a self-assessment tool, that you realize that this is sort of the main goal of what we aim to achieve. This is guiding anyone that wants to use the tool into identifying the main components and main domains and aspects of, let's say, product development and product exploration. But it's up to you to actually implement that and to identify these gaps and actually use that for your benefit and of your company's benefit. I'm going to go back to my slideware. I don't have that much time, but here you can see a very beautiful picture. We also have quite a lot of in-depth tools, as we call them. I'm not going to go into detail in all of them. I want to just mention that the first 3, so the knowledge can and then the organization maturity, actually look at your organization and its capabilities to assess these different activities that are required in, let's say, generally product development and product exploration. The new product exploration is just like the maturity scan that I showed, a follow-up tool. In the sense that, as I said, these are all in-depth tools. So actually, organization maturity and new product exploration are, let's say, a very in-depth version of the smart maturity scan that I showed, where we basically go very deep into each of these activities and processes and tasks that should happen or that are happening if you do a business mission analysis, if you do stakeholder needs analysis. So they're more interrelated with the ISO standard than the maturity scan that is more of a generic approach to it. I'm going to focus now on the knowledge scan because we're talking about this introduction and we're talking about the whole process. I think one of the aspects of actually doing smart product development is, as we identify, is a lot of new competences and capabilities are required that an ordinary coffee machine maker would not need. And now suddenly they want to add these sensors and intelligence and communication. So it's this knowledge can help you. It's a very large list. It's based on the FRDS. Nobody will know that, but it's basically the Flemish Research Discipline Standard, if I'm not mistaken. So we use it 2019, but we just recently learned that there's an update of this. So we will also update our tool to the new 2020 standards. What is this? It's basically an overview of all competences that are related to this product lifecycle realization. So it goes far. The ones that you can see are related to communication, and you can see that if you're really looking for specific expertise in a certain domain, I mean, it's really difficult to identify this. If you're looking for scientific, let's say scientific advice, these are all of the types of domains, and they can help you search, but they can also help you set targets if you need certain expertise in these domains. That's basically it. I'm gonna wrap up. Want to go back to these phases that we defined here. So just these are phases and milestone. It's what I wanted to say is low cost evaluation is key. Stage gating, it's exploring and validating, and we validate the whole story. So that's not only the product itself, it's strategic fit, it's let's say product concept, but also life cycle concepts, business models. It's maybe at the end, as you can see, system exploration. This is already looking at, let's say, the enabling system. So what do you need to actually produce or maintain or support this or create or design this? And so enabling system, what are the system boundaries? Which technology could we select? And this, all of this, if at the end with a validated concept, we should actually be able to come up with a very clear project plan for planning, specification, and then implementation and development. Geert explained it. So the overall scope is to validate whether the concept is feasible, desirable and viable, where we look at it's an iterative process. Does our solution solve stakeholder needs? Is the technology ready? Is it available? Do we have the necessary expertise? All of these aspects, and of course business related. How is the market looking like? What the competition? What is the ecosystem? Could it be profitable, etc. Why do I say this? Because we have two other webinars still upcoming. The first one is the 3rd of June. This will zoom in to let's say the first two phases of our process of exploration. It's basically we're gonna dive into these two topics. So how to understand and validate the needs of your stakeholders, both internally as externally, and of course, how can you come up with business requirements? And what we aim to do is actually come up with with a set of tools and activities and methods that you could use or that are typically used. Now, I think some of them you might know, some of them are completely unknown or maybe irrelevant for you guys, but we're gonna try to fill 1 hour with actually making more practical practical presentation how to actually do this. So think of IP scan. Maybe some of you do that. Maybe some of them never have done that. It could be PESTEL studies. It could be it's interviews if we're talking about stakeholder needs. Can be desk research. I mean, there's a lot. There's a lot. The same for our the third webinar that we are organizing the 17th of June. So we focus on these last 3 aspects of coming up to, let's say, a validated concept. So we're focusing on the validation, and of course, how to come up with life cycle concept, how do we define stakeholder requirements, and how do we do this system exploration. So think of rapid prototyping techniques, business models, types of testing like Wizard of Oz, how to define or set critical performance measures, and how can you see or define enabling systems, etc., etc. That's basically my presentation. I don't know what time it is. It's probably way too late and people left. I did not see you guys. I did not see if anyone put his hand up. I just want to say, if you want to implement one or more of these learnings or the things that we've mentioned, as let's say the Smart Product Maturity Scan, there's 2 things. You can actually have sort of a trajectory with industry partnership. It's together with Flyo. Basically, we have 2, how do I say, offers. But either we can help you orient, so that's actually early in the process, or we can help you validate certain concepts. A large part of it is subsidized, and so basically the orientation is that we prepare and orient based also on the maturity scan, so you will be forced to fill it in, but that will help us do a 360 evaluation of your idea and explore the desirability, feasibility, and viability, and of course help you define activities that could actually, of course, do this. So the concept validation is, of course, also preparation orientation based on our maturity scan, but then we will focus more on validating, again, this desirability, feasibility, and viability. And of course, both of them is sort of an interactive session, so we will put the experts necessary there that combines, let's say, subject matter and innovation management. If that's nothing for you, but you do wish to implement what we just showed you, you can also just contact us, and that's my last slide. So that was it. I think these are the dates for the next webinar, so the 3rd of June and the 17th of June. And then I only rest me to wish you and embrace a better life and also a very nice weekend. So that's it. I'm gonna stop sharing so that